This is our data. We know that it fits an exponential equation because when we put the table into Desmos and fit a linear and exponential equation to it, we found that the exponential equation fit it better than the linear. The exponential equation that fits best is y equals 197.367 times 0.775 to the power of x.
This graph shows that this is not a linear equation. It shows each point of the table that we made in the process of bouncing the ball.
The starting height of the golf ball was 200 centimeters. The ball bounces to 66.1% of the previous height. The equation is y equals 200 times 0.661 to the power of x.
The equation is obviously exponential because it has a pattern in that when placed on a graph is not linear, since the difference is not the same for any of the y points. For example, the difference between the first and second, 131 and 91, the bounce is 40 centimeters, and the difference between the third and fourth, 59 and 44, is 15.
The kind of equation that would be best is an exponential equation.
We chose an exponential equation because in the graph the line has a slight curve to it, and in order for it to be linear, the line has to have no curves and be exactly straight.
The parameters in this equation are 201 centimeters, which is the starting height of the ball. 0.796 is the amount the ball decreases in its height after each bounce.
Bridget and I used a linear equation to model the Bouncing Ball Lab.
It goes down by a constant rate and forms more of a line than the curved line of an exponential function.
The y-intercept was 185.222 according to Desmos.
The slope was negative 24.4167.
Bridget and I used a linear equation to model the Bouncing Ball Lab.
It goes down by a constant rate and forms more of a line than a curved line of an exponential function.
The y-intercept showed that the ball started at a height of 185.222 centimeters.
And the slope showed that the ball decreased at 24.4167 centimeters after each bounce.
We found that in this particular situation, you can make an exponential equation and it can be graphed as a function, mostly because its curve makes a graph kind of shape, and that goes along with the exponential equation and formula. A is the initial value, which is 221 centimeters, which is near the starting height of where the golf ball was dropped. B is the rate of change, and in this situation is the constant rate the ball changes every time it bounces. X is the number of times the ball is dropped. And that wraps it up.